Okay, so we're going to start analyzing the data for our double star. The first thing I'm going to do is in AstroImageJ, open the file, and here we go to the file, pardon the cat, and open. Now, I've already plate solved this one, so what I do is I zoom into this double star here. Now, in order to use this function I'm going to show you on AstroImageJ, you have to have a mouse with a central button and a central wheel. So I want to be able to sort of distinguish these stars, so I'm going to turn the gain down here. Now notice we're still going to have all the data in the file. This just makes it easier to see what we're doing. So you can see my little central aperture. That's the central blue circle. I have that set at, I think, 2, but let's double check. Set aperture size right here. It's set at 3. I'm going to set it at 2 first. Okay, and I'm going to just click with the central mouse wheel right there, hold down that button, and move over here to try and find the center of the second star. And notice it brings up this measurement table, shows the file name, and it's measured the arc length and the position angle for us, as well as the delta magnitude, the difference in brightness or magnitude of these two stars, along with a lot of other things. And it shows the aperture radius, so that's that inner circle. Aperture sky inner and aperture sky outer, what those refer to are, let me show you, I'm going to clear this measurement. You can see the outer circles, blue circles. It's basically comparing the brightness that it measures in the inner circle with the brightness of the sky background that it's measuring. So in that annulus, that outside ring. So that's what that's measuring. So what I'm really interested in right now is if these are consistent measurements. So I'm going to click again, hold down the mouse wheel, move over here, and measure again. And notice it's a slightly different measurement. So that is always concerning. We really want this to be consistent. I'm going to do it a couple times, and we can maybe analyze or do statistics on that data. I'm going to set this again here, trying to find what I'm just estimating the center. And okay, now notice here it wasn't able to make the measurement, and so it put in that there was no arc length, no position angle. If it shows up with this red, it's not making the measurement. I think it made one measurement before that, but I must have double clicked or something. So I'm going to clear those again, turn down the gain there, and do it one more time. Try and find what I think is going to be around the center and go over there. And okay, good. So now it's giving me the same measurement it gave the first time for arc lengths. Now notice that's in minutes. We're going to change that to seconds. If we multiply that times 60, that'll change it to arc length or separation in seconds. Okay, so I'm going to do this just a few more times because the more times we do it, we just want to get sort of an average. The more times we measure, I think the better statistics we'll get. So estimate the center, estimate where the center of the other one is. Okay, and it's being pretty consistent. That's a good sign. Now I always like to check something here. I'm going to change this to a slightly larger aperture, to 3. Okay. By the way I did that is go to set. You can see this set aperture right there. And I'm going to turn this gain down, and I'm going to do the measurements again. So notice what it's doing now is measuring a slightly larger area on both of these stars and figuring out from all of that, hopefully figuring out what the center of that star is based on all the counts. Now what I want to point out is the value of the counts, or the sort of brightness of this area that we're measuring. If you look up here, it'll give you the value right here. And what we want to make sure is this is not saturated, and it's far from saturated. Saturated would be 65,000, a value of 65,000 there. But we can compare that to the surrounding area. So here we're at 3,463, and then if you move towards the edge of this star image, it's a little lower. But if you go out to the sky, it's down in the 600s. So we're not saturated. But I have this larger aperture, so I'm going to do these measurements. Hold down that central mouse, and we got significantly different numbers, but I'm going to zoom in here. We can also tell it doesn't seem to be able to measure the center of this dimmer star. I'm going to clear it and try it again. And see if we can get, so if the apertures overlap, it really cannot find. So the problem here is if I let the apertures overlap so I can center on the second star, it cannot do a measurement, as we can see over here. I'm going to clear that again. Try again. Don't overlap. Again, it's giving us this 1.2 and 1.3 value instead of the 0.98. So what I'm going to sort of guess from this is that this aperture that I'm using is too large for these stars and this finding the center, essentially. So I'm going to go back and set the aperture down to 2 again. Clear these measurements with this broom. Okay, and try again and hope that it's finding the center of the star based on the counts. And we're getting back to our original data, so that makes me feel more comfortable that that's a good measurement. Okay, so that's this one image. I'm now going to do this same thing on a bunch of different images. So notice when we take this data into an Excel spreadsheet, we're going to want to delete, actually I can delete here all the ones that say 0, 0. That just tells us it didn't measure correctly. So actually I can just go edit, clear the ones that didn't measure. Clear that and clear that. Now what we're going to do is when we take this data in and analyze it, we can be pretty confident that number 6 and 7 here are not correct, because we saw that it wasn't really able to find the center of the stars according to what we were looking at. And those are with the aperture set at 3. So I think it's important we can say it was fairly consistent with the aperture set at 2. In fact, you know, it has 4 of the same value, 0.098451, and 2 of this other value, which is pretty similar, and our position angles are similar. But we can talk about that and say it didn't seem to work with the aperture set at 3, but it did at 2. So what I'm going to do now is actually just copy all of this data, select all, copy, and see if I can't get it into my spreadsheet here. There we go, and now we have all of our data, and we can easily analyze these things. So remember, these ones are set with aperture 2, but it shows, or aperture 3, which it shows us right here. Okay, so we'll separate that data out. Okay, now I'm going to show you how I plate solve, which means I'm going to go to the second image, which I don't believe had been plate solved already. And this means we're going to put it into a program that tries to look at the stars that are in here and figure out exactly where in the sky this is, so it gives us accurate measurements of where everything is. Plate solve using astrometry.net, so I already have an account there. It's free, and you go get your number and you can put it in this program, but it's finding some stars, and now it's matching this to a pattern on the sky. So it sometimes takes a few minutes, sometimes it doesn't work if it doesn't have enough stars. I suspect this will work. So you can see here it's Astrometry Submission, it's processing. So Astrometry, polygon, Astrometry Submission, astrometry is the measurement of star positions. So it's trying to figure out where we are in the sky. And sometimes things don't work out. It said plate solve failed. So what I'm going to do is I'm going to actually go to that program, astrometry.net, and upload the file and see if it works this way. Sometimes it does. So I'm going to select the file. We're going to go, let's see, documents. This is the data we're working on. There we go. Team 3. It's this second one, I believe. Select the file, we hit upload, and hopefully this will work. Okay, bear with us while we process it. Usually 10 minutes. I found it's usually less time than that, but we're not going to sit and wait. We're going to do other things to be productive. Okay, it has successfully plate solved. It says success here. We'll go to results page. Alright, excellent. And there it identifies it. This is the Henry Draper catalog, so it found that's our double star. one thing that we want to pay attention to here is the pixel scale. Now this is interesting. Pixel scale, 1.14 arc seconds per pixel. So for each pixel on the sky, it's saying it's 1.4 arc seconds based on knowing where all these other stars are. That's very accurate. Also notice this, up is 88.1 degrees east of north. So I'm just gonna copy this information. It also tells you other things like the size of the image, 29.8 by 20.1 arc minutes. And it gives us the center RA and deck here, which is really useful. In fact, I'm just gonna copy all of that. Copy that and go put that over by this. This is our data, just so we have that information for reference, especially this arc second per pixel. So now I'm going to show you something else. If we go back to our image, which one was it? Not that one. Okay, so I'm actually going to reopen the image. That would be this one, second one. Okay. So I'm going to reopen the image. Should be this one. Okay. And we can look at the FITS header. Let me bring that over here. And notice pixel scale. If I can find pixel scale. This is all the information, the metadata about this image. Where's the pixel scale? Okay, so down here, number 71, pixel scale, 1.16 arc seconds per pixel. That's what was put into the program on the camera that's on the telescope, which is a little different than the 1.14 that we got. We're going to trust the 1.14 that we have in from astrometry.net. So we can close the FITS header. And in any case, we can do measurements on this just as we did on the previous file. So I'm going to turn down this gain here, I'll zoom in so we can see these things better. I'm going to make sure my aperture is set at 2, which it is, okay? And let's measure here. Boom, boom. All right, and this number is very similar to what we got on the other image, which is encouraging. So let's do a couple of measurements just to make sure it's consistent. Okay, now notice I didn't have to turn down the gain to get a consistent measurement. It seems to be measuring fairly well, fairly consistently, I should say. But I, sometimes like to just be able to see better what I'm doing. And you'll notice if I click slightly off center, it will move it to what it calculates to be the center for me, which is what it's supposed to do. It's centroiding, finding the centroid. All right, so I'm going to do this a couple of times, and we're getting the same measurement every time. That makes me feel better. I feel good about that. Now, just because it's good to experiment with things, I'm going to make this one have a larger aperture and just see what we get. So let's clear those, and I'm going to zoom down again and change the brightness and see what we can get in this case and see if it gives us the same sort of inaccurate measurements. It's similar to what it was for the other image, but notice it doesn't seem to be centroiding properly. That one just doesn't look right. Now, that doesn't tell you everything, but I'm not sure. Okay, so now we'll do one more measurement with this larger aperture. Okay, and it's not being consistent, which is interesting to note. We'll do one more. See, maybe that's the center, and maybe that's the center. All right, so fairly inconsistent. So somehow there's too much overlap of the information in these, and it can't centroid or something like that. So I'm going to change the aperture size back to 2. Hit OK down here, and do one more just because. Centroid, centroid. We're back to our original measurement. I'm confident with that now.